But back to the best way to handle it. Copper is an easy material to handle once you learn how. If you want to roll this out and get it straight, you see what I'm doing. Okay? That's the way to do it. Okay. Now, it does come in a roll, usually 50 feet rolls, or it can come in lengths, 20-foot lengths. The 20-foot lengths is hard copper. It's not pliable like this or flexible like this. But that doesn't mean that we can't make it that way. We're going to get that in another lecture, but we're going to look at flaring today. And then we'll move into some brazing and soldering come Monday. All right, I want to make some flares. First of all, if I do not have a good cutter, I'm wasting my time. If this wheel, this cutting wheel, has notches in it or imperfections, it's going to show up in my flare. Okay. I'll pass this around. I think if you'll look at this kind of close, you'll find that there's a couple of little nicks in it. It's not the best thing to use. Okay. When I go to cut the copper, put my cutter on there, and I move it around. I tighten each revolution that I make. I tighten the wheel a little bit more, and I'm actually pinching the tubing apart. There we go. Now I'm going to leave a ridge on the inside. That ridge needs to be removed. So I ream it. Okay. Now the fitting, the copper fitting, should be put over the pipe before you make the flare. Now I've got a couple of different type of flares blocks out here. Flare block, here's the yoke. This particular one has a cone that is stationary. When you tighten it down, the cone does not turn. It presses the flare into the pipe. I have another flare block here that actually rolls the copper out. Okay. I'm going to try my luck at this particular one. I'll tell you what, let's do the older one first. I say the older one, this style has been out for who knows how long. I want to put the copper in the proper hole there. I want to have the copper extended past the block about, a lot of people like to use a dime. Okay? About the distance of a dime past that. As you do this, you'll learn some of the little tricks. Tighten the wing nut down that's closest to the pipe first. And then tighten the other side. That way you have the leverage of the block itself to help get that in there. Okay. I should have had a little oil up here and I don't. I need to put a little oil on the end of that cone. That is the one that presses it out. Another thing with this particular one, I should have actually took a file and flattened it off the top too. I thought I was going to use this one. I will in just a minute to show you how that difference comes into play. Okay, once that bottom's out, back it off, and you should have a flare made. Let me tell you, if you have to use anything other than your fingers to tighten these up, something's wrong. I see these things get broke all the time. You shouldn't have to use a wrench on it at all. You can see the flare. It fits down into the nut. Now, this should fit into that nut without having to thread the nut down on it. It should go over the fitting where it fills the outside of that fitting up completely, but not past the edge of the fitting itself. If I have to thread this on here, that I have extended that copper too far in the flaring block to do that proper job. If it's not enough, then I'm not going to get the seal. The seal of a flare is between this part and this part. If I have to tighten this up to the point of causing something like that, there is a problem. Y'all see that flare has been busted? It's been over tightened. Okay. Now, I like to put a little bit of oil on here. Usually want to use the oil that's going to be in the system on that part and the back part of the flare here, so that it helps helps eliminate any resistance of that pulling down properly. I want to show you a little something though. If this has been dropped and there's defects in here, it's not going to seal. Now, you don't think about that, but most of the time these come with a little cardboard sleeve over. But if that cardboard sleeve gets lost, this gets bounced around or dropped, it's going to cause a defect right here. In fact, this one actually has a little defect. I'll pass it around. And it's not going to tighten there. So keep that in mind. All right, once you do tighten that up, you don't, like I say, you don't want to over tighten, but it should mate against one another. One way that you can check as you do in this particular lab and learn is if you tighten that up and you pull it back apart, you're going to see a little bit of a copper imprinted on this brass, and you'll see a little bit of the brass imprinted on the copper. That's how it actually seals. Now I'll show you a little something. We talk a lot in the future, or have, about pulling vacuums and using it for testing for leaks. That is a no-no. Okay. If you have a system that holds a good vacuum, most folks are going to say, well, hey, that's leak-proof. If they haven't pressure tested it, I'll argue with them, and I'll show you why. If I tighten this down, hand tight, maybe not even that much, the more vacuum that I pull on it, the tighter, I'm going to open this up so that you can see, the tighter it's going to pull itself together, right? The deeper the vacuum I get, the better it seals. What happens when I put a pressure on it? It's going to leak. So using a vacuum as a pressure test is not the best thing to do. Okay? All right. On your flares, the lab that we're going to ask you to do is make one of these. Okay? Need a 1/4 inch on one end, and it's going to come down to a increaser coupler or a decreaser coupler, depending on which way you're going. And then you're going to have a cap on the end. Okay? Now, once you get that built, we're going to hook it up to a bottle of nitrogen out here, and we're going to leak check it. Okay? Be selective in the fittings that you pick out in our supply. If they've been dropped, let somebody else use them. Okay? Be selective. Now, I'm going to ask you a question. What happens if it leaks? That's the answer. How many people are out there doing service work on a job? How many people do you usually see in a service truck? One.
One, maybe two.
Okay? Maybe two, but most of the time it's one.
Yeah.
Okay, so if you got something that didn't go right, who are you going to get to help you out?
Yourself.
That's right. So if you got a leak, you got to fix it.
Yeah.
And I can tell you, if you don't know how to flare, and you don't get the soldering and the brazing down that we're going to be going into next week, you're probably not going to keep your job. Because if you got to call the boss and say, hey, I need some help out here, I can't get this pipe sealed up, he's probably going to get you some help. Help you out. All right, any questions that we need? I didn't point out some things that I should, and I'm going to catch this as the very last thing. I had them laid out here and I didn't cover them. This is what you use to put the threads on a iron pipe. Okay, this is the die. Okay, the cutter for the iron pipe, right there. Don't be using one of these on iron. It's made for copper, aluminum, that's it. Pipe wrench. Pipe wrenches should not be used on brass. You want to use adjustable wrenches or flare wrenches. Something without the teeth. But on the iron pipe, you need something with the teeth to get the body. Okay? When making threads, like I said, I didn't cover this earlier, you want to use the proper lubricant. You can ruin these dies by not keeping them lubricated. And it depends on what material you're using. What I mean by that, iron pipe, you're going to have some cutting thread oil, okay? Thread cutting oil. If you're, and you don't think of this too often, but this is Schedule 40 pipe. They make a Schedule 80. Schedule 80 can actually be threaded, okay? But you wouldn't want to use a pipe threading lubricant on it because the plastic itself acts as a lubricant. You don't see that a whole lot, but you will. From time to time you will. And I didn't go over a whole lot about the sizes, but these things are, the pipes are rated for certain pressures. Pay attention to that. You have, in copper, you have an L, an M, and an N rating. Okay? Each one has its proper place. Some can be used for all, some cannot. Some are very thin walls. Non-pressure system. Yes.
The ratings are on the tubing and the copper itself.
You should have the ratings on the or on the box. You probably won't find it on the copper itself. They're going to be on the box. Now, most of your iron pipe is going to be on it. PVC, you do have the rating on it. Okay. Any questions?